For question 6, we want to look at what's the total sum of the positive charges in a litre of hydrochloric acid of pH 1, and to do this, prior knowledge is assumed that you're aware the equation for relating pH to concentration is pH is equal to minus log H plus, which essentially means that the pH is the negative log of the concentration of the ions in the solution. So this is the concentration of H plus ions. So our value of pH is 1, which means 1 equals minus log H plus, like so. So a standard log is log to the base 10, which means if we multiply out this, if we solve this log for H plus, then we want to first move the minus over to this side, so we've got minus 1 equals log H plus, and that means, like I said, it's to the base 10, which means we can then multiply out, we'll have H plus on this side equals to 10 to the minus 1, like so, which means the concentration of H plus is 0.1, and that's in moles per decimeter cubed. So you need to be aware of that equation. And then once you've got that equation, you know what units it comes out in, then you can get the concentration quite nicely. So we know that 0.1 mole in 1 decimeter cubed is 0.1 times Avogadro's number, and that will get you the number of hydrogen atoms present. Sorry, that times looks more like a K. Just to be clear, it's a multiply. So times Avogadro's constant. Avogadro's constant is 6.022 times 10 to the 23, which means we're timesing it by 0.1, so we get 6.022 times 10 to the 22. And that's the number of hydrogen ions in the litre cubed. Sorry, in the litre. 1 decimeter cubed is 1 litre, just to make that clear. So we've got this as the number of hydrogen ions, and then we're told the charge on the proton is 1.6 times 10 to the minus 11, and we're told, no, we're not told, but we know that hydrogen is a single proton, so we then times this thing here by the charge of the proton, because each of these has a charge of the charge of a proton, so we times that by 1.6 times 10 to the minus 19, and that gets us 9,635 coulombs, and that's our answer. So you need to be aware of the equation that relates pH and the concentration of ions, and then you have to use the knowledge that 1 mole, or that a mole is 6.022 times 10 to the 23 individual atoms. That's Avogadro's number, and that relates a mole to the number of atoms in a solution. So once you know them two main things, the equation and Avogadro's number and what it actually means, then you can then go on and quite easily find the total charge of all the ions in the solution.